Nice to see you. Thank you very much.
Good to see you all. Good morning. Lovejeet,
Morning.
good morning. How are you? Or Rajesh, I know you're back in Asia now.
Yeah.
Okay.
So good afternoon for me.
Good afternoon to you. Good morning to those in Belgium, and good evening if there's anyone dialing in from Australia. But good to see you. Good to see everyone. Thank you very much, and really excited that we can get together today. It's such an important topic. Given that transmission is really, a pivotal fulcrum within the energy transition that we're all, working on to make happen. So we're at the start of the hour. So without and I believe we have everyone on from Elia Group. We have Didier, Rajesh, and Lovejeet are all on. And then from our side, ADB colleagues are joining here in person within the Manila headquarters as well as online. And this session will be recorded. So maybe I could just kick off just to give a warm welcome to everyone joining today for this webinar on digitalization for smart, resilient, and interconnected transmission systems, which is jointly hosted by Elia Group International and the Energy Sector Office of the Asian Development Bank. I'm Christine Chan, Senior Advisor to the Vice President for Market Solutions. So we cover both the private sector operations business of ADB, as well as the public-private partnerships and markets development business. I will be your moderator today for today's webinar. Now, I want to first start with the why. So I touched earlier on energy transition and the criticality of transmission. But just to take a step back to those who are maybe some of the colleagues who have joined may not be energy sector colleagues, and we have bank-wide participation. So just wanting to give you a backdrop that the energy sector is undergoing a very profound transformation, driven by the rapid deployment of renewable energy resources, the increasing demand for electricity, driven by energy-intensive data centers. We see every day there's increasing usage of data needs, driving electricity consumption through electric vehicles, and also the emergence of new technologies such as green hydrogen into our energy source, and also new business models that we are seeing, which is creating a disruption in our traditional power distribution system, such as through C&I rooftop solar generation. So these changes pose significant challenges and opportunities for the planning, operation, and management of transmission systems, which are the backbone of the power sector. And I wanted to share with you some data, since we're all very digitally and data focused. So according to a recent study by the International Renewable Energy Agency, the region needs to invest about 1.7 trillion in transmission infrastructure from 2020 to 2050 in order to achieve a low carbon energy transition. So this investment would cover the cost of not only building new transmission lines, upgrading existing ones, and also deploying smart grid technologies. And this study also estimated that the region would need to increase its transmission capacity by more than 4 times, from about 8,000 gigawatts in 2018 to about 35,000 gigawatt in 2050, to accommodate the growing electricity demand and the higher share of renewable energy sources that we all hoped can be achieved. Now, the study also suggests that the region could benefit from enhanced regional cooperation and integration, which is also an area where ADB is taking a very active role in trying to realize the ASEAN power grid, for example, in the Southeast Asia region. And we have other similar examples from South Asia and other Central West regions as well. And the regional cooperation and integration could actually generate significant transmission investment cost reduction, reducing it by about 9%, and save about 150 billion in cumulative costs by 2050. Moreover, the study also highlights the co-benefits of the transmission investment, such as creating jobs, green growth, reducing greenhouse gas emissions, so contributing very much to our climate mitigation financing, improving air quality, and enhancing energy security and access. Now on to the how with our experts and speakers today. How can we ensure that the transmission systems are smart, resilient, and interconnected to cope with the changing energy landscape and deliver reliable, affordable, and sustainable electricity to consumers? And secondly, turning over to digitalization. How can digitalization enable transmission system operators to optimize their assets, enhance their services, and integrate more renewables? I think these are all questions we're really keen to hear more on from our distinguished speakers from Elia Group International, a leading transmission system operator and consultancy firm in Europe and globally, and really look forward to the insights and expertise on how digitalization can support smart and resilient transmission systems via more interconnected and resilient transmission systems. So let me first turn over to Didier, Lovejeet, and Rajesh. Over to you. The floor is yours. So we will start with your presentation, and we will also save some time for Q&A towards the end for interactive discussions. I hope everyone will chime in with questions. Feel free to raise your hand on the chat if you would like to share any questions or would like to unmute and speak up during the Q&A portion. So over to you, Didier. Thanks.
Yeah. Thank you very much, Christine. Thank you very much for organizing this event and absolutely share your views that transmission is absolutely key, not only in Asia, but globally. So my name is Didier Wio. I'm the CEO of Elia Group International, which is a subsidiary of the Elia Group. I will present you quickly in a minute. I've been working in the energy sector for more than 25 years. I started actually in the energy sector in times where this was not unbundled, where transmission was not unbundled in Europe. So I've been through all these sequences of splitting the energy sector in pieces and then trying to develop the transmission because, as you mentioned, we all believe and as time goes by, we even more believe into this, that there is no transition without transmission. So for us, the hearts of the system, the veins that are connecting everything is really the transmission and distribution system. So this is our main focus, I would say. So what I will do here is go through a few slides. Of course, it's a very large domain. We cannot cover everything. Yeah.
Sorry, Didier. Yeah.
Would it be possible to put it in presentation view so that we can see the full slide?
Yeah.
Yeah.
Thank you.
I'm not controlling it, but I know Lovejeet maybe. Yeah. Okay. Is that better?
Yes.
Yes.
It's great.
Thank you.
Thank you.
Okay, perfect. Sorry for that. Yeah, so about the Elia Group first, maybe. So Elia, as Christine was mentioning, is one of the largest transmission operator in Europe. So we own basically and operate the transmission system in Belgium. So we cover the full country there, and we also operating a part of Germany, which is called the 50 Hertz area. Could be confusing the name, but the name of the company is 50 Hertz, and we are operating a grid at 50 Hertz for sure. So with those two transmission utilities, we are covering quite a large part of Europe. We are also connected to the North Sea and to the Baltic Sea, and so we are tapping also quite a lot into energy that we are developing at seas more and more. It's also worth mentioning that we are the zone in Europe which has integrated the most renewables so far, and so operating this system has become quite a challenge over time. So as I was mentioning, we have Elia operating in Belgium, we have 50 Hertz operating in Germany, and we also have what you see on the screen is NemoLink, which is one of the first interconnector. I will get back to this one because this is a very important one, connecting Europe, basically Belgium and the UK. And part of this constellation, we also have Elia Group International, which I will come back a bit later. I'm the CEO of that part. We also have a company called Rialto, who is also looking into what we call the digitalization. So we we understand that we need to go into more digitalization. We know that without these tools, those modern tools, we cannot operate the system as we did in the past. So we need to modernize this. We need to integrate more flexibility into the system. We need to take into consideration the rooftop PVs, the EVs, electrical vehicles, the heat pumps, and everything which is coming to the system, and make it on one side more difficult to operate, but on the other side also coming with a lot of new opportunities to balance the system better. And also we have WindGrid, which is another subsidiary really focusing on developing offshore projects, because as you know, in Europe and in other places of the world, producing electricity at sea is really becoming central. Next slide, quickly. I will not discuss about the shareholding structure. I think you will receive the slide, so that's more for information. But maybe just quickly mentioning that we are a stock listed company, and at the same time we are a regulated company. So regulation means we are under pressure to make sure that electricity price at the end of the day is okay for everyone. So we need to deliver cheap electricity. So we are under pressure by the regulator to do so. And at the same time, because we are a stock listed company, we also have shareholders, and they expect us to generate also value. So we have a double, let's say, incentive, which is unique globally. And actually this helped us or pushed us to the limit of being more efficient. So I think with this dual pressure, we had to optimize everything. So operational excellence, optimizing the investment, not investing too much. So gold plating is not really our let's say, philosophy. We are more into making things efficient for the benefits of the tariff and of the shareholders. And I think this is probably why we are quite unique in Europe so far. Next one. What is also very unique to us is that we have strong ambitions in Europe. As I said, we have been integrating a lot of renewable energy in the past, and we know how difficult it is to do so. But we want to push even further. So we have a strong commitment to be fully, or actually feeding the loads by 100% renewable energy by 2032. And we'll start with Germany, because this is where we have a lot of potential in terms of wind. And 2032 is tomorrow. So we already need to develop the technologies, invest in infrastructure. And it's much more than just building lines. Building lines is still the easy part of that. So the complex part is operate a system which integrates a lot of renewable, and that's a huge challenge. The topic of the day is really about interconnectors, but I will discuss that later. For us, this is absolutely non-possible without interconnecting more and exchanging electricity across borders. So quickly on Elia Grid International. So as I said, so our mother companies are the operators, and by law, by regulation, they are focused on the local and national markets. Now, over time, we got lots and lots of requests from utilities globally, private developers as well, donors, to assist projects based on our experiences. And so, okay, that was difficult to do through our regulated entity. So we created Elia Grid International. And the goal really here is to leverage the expertise we are developing, and we developed over the past decades, and make it available to people willing to go the same path. So I was mentioning we are interested in all topics which are related to transmission, and it comes from first developing the grid, because of course you need the infrastructure. So we can, and we do that every day in our home base, let's say Belgium and Germany. So develop the grid. We operate the system as well. So we are developing all technologies to make sure we can operate complex system. Of course, our target is to integrate more renewable energy, and that's also part of our mission. And maybe something which is less known, but very critical to us as well, is we are really pushing hard to develop electricity markets. And we were one of the first in Europe to implement the first electricity market. So connecting different countries and starting to share energy based on pricing. And again, this was the starting point in Europe. Now we have a full electricity market in place. But again, we don't believe building assets will work if you don't have an electricity market. And so this is also a very critical part of our activities. Yeah. So next slide, yeah. So EGI over time, we grew, and so we have offices spread all across, let's say, the board. So of course in Europe, where we are very strong, but the Middle East has been integrating a lot of renewable energies recently. So we are helping them over there. And recently, more recently, Asia and Southeast Asia especially is one of our focus. We've been working with some utilities over there, and we recognize that what Southeast Asia is going through now is very close to what we knew in Europe a few years ago. And we believe that we can help fast track what's happening in Southeast Asia based on our experiences in Europe. Yeah. Next one. Yeah. And as I was mentioning, so we can assist on everything related to power transmission distribution. I would say we are not really a consultant company, even though, yeah, we are helping with our services. But the big difference is like we are not selling slides with ideas. What we are pushing to the market is experiences that we implemented in Europe. So we did a lot of mistakes in Europe, and we are still doing some, I guess. But we also found some ways that were working quite well. And so this is what we like to share on the market. So what we do is really based on practical experiences of what we did in the past, but also what we are pushing now in terms of innovation, in which we strongly believe. Right. Yeah, okay, we can skip this one, I guess. What I wanted to share with you a little bit today is some of our past experiences. I mean, everybody knows about what the transmission, what the interconnector is, and how is it working. I will get back to that, but I just wanted to mention one or two examples here. So one of the first is the NEMO-Link interconnector. So you know NEMO-Link, and the reason I'm mentioning here is first because it was state-of-the-art interconnector that we developed between Belgium and the UK. State-of-the-art in terms of technology, and still one of the only one being used at these days, let's say, with that voltage level and that technology. And at the same time, it's one of the best performing interconnector in the world. So we have, let's say, the best track record in terms of reliability. That means from time to time, we say you can use top level technology and still secure reliability. So that's what we like to do as investor. We want to invest in technology that are robust. So it's perfectly feasible. That's one thing. Second, very important, is we innovated there in terms of regulation. So again, the business case of that interconnector was not very positive when we looked at that. And so, the classical regulation didn't really make it bankable, or we could not really invest to make it happen. So actually, we innovated there in terms of regulation, which was also one of the first interconnector where we introduced new ways of financing and also getting the money back. Again, this is showing that not only technology, you can test the limits, you can also have very good track records, and at the same time you can innovate in the regulatory framework to make it happen and make it very profitable at the end of the day. So that's one of the very strong track record we have in Europe, and everybody is looking at that link as a reference today, and I think it still be the case for the few years to come. Next one, which is also very interesting, is what we call a hybrid interconnector. So here in that case, we have a link between Germany and Denmark. So you can say, okay, that's a classical interconnector. But again, the case was not very positive. So it was like, yeah, it's interesting, but can we really finance it? Does it make sense? And then we introduced a concept which is very interesting as well. It's like in the middle of the interconnector, we are connecting wind farms. And so you see the idea here is to say, look, if the wind is blowing and Denmark needs this, you can push it to Denmark. If Denmark doesn't need that, you can push it to Germany. And if there is no wind, you can still exchange power from Denmark to Germany. So actually, this kind of link is used all the time, and you can use it to the benefits of everybody because it's also connected to renewable. That's a new concept. showed to be extremely interesting economically, and also in countries like Southeast Asia and other places where from time to time the business case can be borderline. Introducing this kind of new idea by plugging connectors in the middle can definitely boost the business case, and at the end of the day you can build this infrastructure. So you see, we believe this kind of innovation not only help to develop the infrastructure, and at the end of the day it makes the infrastructure deliver exactly what we want to do, means giving access to cheap power and opening the market. Next one. We even went further, so we can also look at even more complex configuration. So that's more things that are being done now, but HVDC, long distance interconnectors connecting multiple points, again to optimize the cost of this. So these solutions, we are developing them as we speak. And the beauty is that Asia will probably benefit from those technologies once they've been type tested, basically in Europe and other places. Yeah. So, what I wanted to show here is based on these experiences that we have through these new, let's say, approaches. Many countries and many developers are looking at the very same technology. So this is just showing you the project on which we are assisting. Because we believe those projects are critical to share power across continents, even to feed Europe with energy coming from the south, from renewable energy from North Africa and from the Middle East. But at the same time, those projects, they need to be realistic in terms of money. And so this is exactly where we can contribute. So looking at the technical solution, but also looking at the regulatory legal part to make sure this project will really be beneficial. And the same happens in Asia, where we already have some contacts. Lavjit, next slide, maybe. Yeah, you see, we also been contacted already by few utilities in Asia to look at these projects. We are working today on this interconnector between Australia and Tasmania. We have been in touch with other challenging projects, and interesting for us is, and this is where I met Christine last time, is there is a willingness, to look at those solutions in Southeast Asia, especially Singapore, Sarawak, Malaysia, Vietnam, Thailand, and I think the time has come to really look at what we can really do and make sure this is economically okay. So that was more for what we do as EGI. Now maybe I want to talk a little bit about the challenges we've been facing in Europe, and I think this is very interesting. Interconnectors are not new for us, and we've been working on interconnectors for years and years and years. The thing is, when we started to build connection across country, the main purpose was really to get access to cheap power. So there was a cheap power coming from east, so it would be interesting to connect and buy power from the east. You have nuclear energy from France, and from time to time, it's cheaper as well, so it's good to buy. So actually, we started to develop those connectors to gain access to those things, and also make sure we could balance the system, a bit smartly. Now, what's happening now is completely different. So with the integration of renewable, what we see is every country is pushing for more renewable integration. And actually what we discovered over time is that to push more renewable into the system, you need more flexibility in your system. You need to be able to balance the system. So you have two options, basically. For each megawatt of renewable you build another megawatt for balancing, and then that's absolutely not acceptable. Or the other option is to say, look, we depend on the others. So we can balance our system from energy coming from other places. And that's much more economic. And so this is what led the European market to, look at how to integrate more renewable, but at the same time, to make it happen, to build more interconnections. And we all believe, and we are operating the system now every day and keep the lights on, even with a lot of renewable energy in the system, that would be perfectly non-possible or completely crazy without interconnectors. So as we speak, let's say we already have more than 100 interconnectors in operation in Europe, but with the plans to integrate more renewable, we believe we need to double that number. So we will continue to develop these interconnectors, and Europe is pushing hard to say, let's say, there is no alternative. There is no transition without transmission, as I said. So integrating renewable is absolutely impossible without the interconnectors. And there is even a law now in Europe that is pushed through the state members to say every state members should have at least 15% of its installed capacity should be available as transmission capacity, so that every country could contribute, let's say, to the global effort to integrate more renewable energy. And so we were looking at the list again very recently, but I think we have now 80 projects in the pipe to be built in Europe to do that further. Yeah. Next one. And the reason for that is try to explain in simple words is, you know, if you look at the bar chart on top, what you see there, okay, the years are missing, I see here, but what you see is the amount of power that we've been pushing into the system. And this is the renewable energy that you see. So we are pushing a lot of electricity in the system, and this renewable energy comes from two sources. You have on the left the large, let's say, wind or solar farms that are bringing, you know, megawatts or gigawatts of energy to the system. So you can consider that as bulk power transmission or generation. But at the same time, we've seen millions, literally millions of small units, generation units coming to the system. So we see rooftop PV, you see small wind farms, you see electrical vehicles, all of them can contribute to the system. And so managing this is becoming a real nightmare. And the next slide shows you a little bit why. So what you see here is, you know, the gray part is the classical generation unit you have on the system, which is the base load of the system. And on top of that, of course, you put the renewable, the variable energy supply that you put on the system. So you see already today, and we have, okay, a lot. So you see a lot of variability, which is a challenge already, but still manageable. We had to develop the tools to manage this. If not, we would have blackouts, let's say, every day. But so we have the tools to manage that. But of course, when you push further and when you want to achieve like 100% renewable in the system, which is our target, then you see that this is becoming crazy, actually. There is nothing stable anymore in the system. You see days where you have too much generation, so you need to do something to do with that, and days where you have no sun, and then you need to import or to generate power from other sources. And again, this variability and all the simulation we run, you can try to manage that with battery storage. You can try to manage that with adding generation supply, but none of those solutions are economically justified. And so that would actually block from inputting more renewable. And honestly, the best, or the golden key we have here to make it happen are the interconnectors. Is the possibility to share power when and where needed to make sure the system remains stable. So again, interconnected for us is really paramount and critical to the system. Just a quick word on offshore as well. Just in Europe, you know, we don't have a lot of sun, even though we have sun, but we have a lot of wind, especially in the North and Baltic Sea. So over the years, we've been also developing a lot of solutions or platforms or connecting generation of the seas. And we know in some parts of Southeast Asia as well, wind is very interesting. We know in Vietnam, there is part of the sea where you have quite a lot of wind. And you know, getting access to that energy and share it in the region would make sense. I think in the Philippines, there's also wind, even if it's less than in Europe. I think it's beneficial, and we can tap into that kind of power. So you see on the screen, we have a lot of experience in that domain as well. We are not really into looking at how to build a platform. Again, we are more into power system operations, so how to make sure this energy can be connected to system in a profitable way. Yeah. Slide. And what is very frustrating for us is what we see all around the place, including in Southeast Asia, is where every developer comes with a great idea to produce wind and wants to connect to the shore with a cable. You know, everyone connects to shore with one cable. At the end of the day, it's not very profitable, and it creates a nightmare in terms of assets. It creates a spaghetti of connection. So we dropped that idea for quite a long time, and we are more into solutions which we call plug at sea, which is like we develop a plug, really literally a plug in the middle of the sea where everybody can connect, which would, let's say, reduce the number of assets you need, optimize the business case, reduce the number of landings on the shore, and solutions like that. So we believe these solutions can not only stimulate the integration of renewable, but it can be also very beneficial in terms of costs and speed of implementation as well. So you see there's a range of technology that are being implemented here that can be beneficial, and we have the expertise in those domains. Yeah. Next one. Yeah, we can, I think, skip this one. We have a lot of reference, of course, that we can share with you, but I think that's the main idea. Of course, there's a lot to be said on interconnector on the market. I think the Q&A will be a good place to do that. This is just basically an introduction to the topic, and please don't hesitate to ask anything. Happy to answer any question. But I think first we go through the digital parts.
Yeah, thank you.
Yeah.
Thank you, Didier. That was a really great introduction on interconnection. I think we all have a lot of questions that we will be bringing up. You know, it's very relevant, very topical to the work that we're currently engaging on in the regions. But why don't we turn over to Lavjit first on the digitalization innovations that he's been leading at Elia Group. Lavjit, over to you. Thanks.
Yes, thank you. I hope I'm audible well enough.
Yeah. Yes, good. Thank you.
Great. Yeah, I think they talked about this. Infrastructure is coming on both sides, and that's making a bit the operations complex. I come from a markets background as well, so I understand the importance of flexibility, and where interconnectors bring a more long duration flexibility to our grid operations. At times, we also need a very strong response time based flexibility, something that can be activated in seconds. And there, I think Belgium has kind of led the way in designing a consumer-centric market. And we are gone past that mindset where we need OCGTs, small turbines of 25 megawatts, peaker plants, etc. No, I think we have done a lot of work in getting even flexibilities from households, from their electric boilers, from their EVs, from their residential batteries, and the right kind of aggregation and market mechanisms needs to be put in place to enable all that. So in a way, in EGI, I entered a bit the digitalization space by serving that part. And then we also understand when there is a lot of renewable integration happening, the systems are getting widening through these interconnections. That brings a kind of low inertia, and you need really advanced tools to manage it. So a lot of focus has been given on our control center operations and how do we need to basically modernize it to meet the future needs. Also, I think it's integrated. I mean, we need to see smart grids more as a unified grid. We are also facing a lot of challenges at the downstream networks, where there is bidirectional flows, and we are not far from days when a whole street will have some 20 EVs and every second or third household has a rooftop. The behavior of the customer is similar. If they all start coming and doing the same things at 7 p.m., 6 p.m., the grids are not designed for that. So you really need to put in a lot of controls and mechanisms even at that layer. The market is helping us. There is a lot of partner and supplier ecosystem supporting the grid utilities. A lot of technologies are there. But the problem with so much of technology is that if you don't have a view to make them work in tandem, it causes more issues later in terms of integrations and exchanging information. We also don't want that. And there is also a growing concern about the lack of digital resilience we have in our utility IT architectures. A lot of our operational infrastructure, our critical infrastructure, is susceptible to cyber attacks. It's only increasing year on year. And what we have felt is there is also a very low data governance maturity in utilities. I think we are not considering data very seriously. It was also the case at Elia 5-6 years back. We have gone through a massive data transformation journey. And I think there is a lot of work for utilities to be done there. So this just talks about some of the complexities we are looking at from digitalization perspective. My next slide talks about, the influx of technologies and systems now available in the market, where you see across the value chain, from generation to transmission to DERs and end customer premises, there are a lot of technologies and systems available. We see on the transmission side things changing, evolving. I think with more and more renewable integration, the functional capability offered by the market also is going to evolve. But today, anyways, we are seeing that as a lot of kind of new technologies are getting integrated at the transmission level with these HVDC and supported systems, your FACTS, your PMUs, DATCOMs, etc. These are the new kinds of infrastructure we need to manage the renewable grids. Even our SCADA operations are evolving. Our EMS solutions are having advanced algorithms, dynamic analysis of the networks, of contingency, of security. So there is a bit of growth in the functional capability of these systems that's required. And also on the distribution side, I think with this influx of DERs, we need to really have a view on how do we integrate and manage this whole layer of assets. So a lot of work has been going on in this direction. And here is where also there needs to be some coordination between TSOs and DSOs, because even TSOs can benefit from that flexibility, but we don't want to do that at the cost of disrupting the DSO operation. So there needs to be a lot of coordination there. So yeah, there is a lot of stuff happening. Even when you look at asset utilization, there is an influx of IoTs that's coming now. We see these small battery-enabled sensors being plugged into several transformers, SF6 equipments, etc. These kind of analytics are also ingested now by the grids to manage their operations. So a lot is happening out there, and I think that's a good sign. We have done most of these projects, and we've supported most of these utilities in getting the right strategy behind this. But what we see is that when you have all these systems coming in, it's now very important that we make sure that they talk to each other, they work in tandem. And here is where I think it was an EU initiative, which has now become a more global framework, which is what we call as a smart grid architecture model. And the focus there is laid on the interoperability. So at the bottom layer, you see all the physical infrastructure coming, all these systems coming. But I think this is the layer which, simply put, generates the data. But how this data is going to be utilized by vertically the entire stakeholders, that's something that there needs to be some kind of design to put behind. So we see, I think the most important thing, when the data is generated, what is to be shared and how is to be shared, that's your communication layer. And this needs to be, there's a lot of work that's happened on this, but I think the latest industry agreement is that we all need to migrate to IEC 61850. It's a new standard. It's a collection of past experiences over the last 20, 25 years. And so far, IC 61850 has only been implemented within the substations at the equipment level, but not at the PAN network from the infrastructure to the operation. So this is a global migration target. I think in 10, 15 years, you'll see almost 50, 60% of the utilities adopting this. It's on everybody's roadmap. We also hear from many of the utilities in Southeast Asia that they've started working on this. They are a bit early strugglers. So we are there basically to bring our experiences on what we did at IC 61850, what are the mistakes we made, and what things work for us. So that's the communication layer. And the thing is, once the data is transferred, then it comes into the systems, it gets processed into some kind of information. But again, this is something that we have observed in utilities. This information was only ingested in silos, but that's not how it should be. I think those informations support many other operations. So there is an interface reference model which the industry has themselves created on how the information needs to be passed on to other businesses. So how it needs to go from, let's say, the SCADA to the asset management teams, or from the meter systems for the metering team, department team, on the markets management team. So there's a lot of information that gets generated at site, which needs to be used by all of them, and how it needs to be designed, that's something we look at. So and for that, the industry has developed a common information model, which is also something which we see utilities in Southeast Asia starting to think about. But we've got a lot of experience behind and how we did that in Europe. So that's a bit the smart grid architecture model. And whenever we go for any kind of digitalization project, this basically is our foundational framework on which we ensure that the systems are there. You get the systems, you design good systems, but please focus on the interoperability part. I want to give one example of from where do we come from vision perspective when we look at, for example, the case of control centers. So on the left-hand side is basically, let's say, the control centers you have today. That's basically coming from these players like GE, Siemens, Hitachi. They are great solutions. They've been supporting the utility operations for years, but now things are changing. The thing is, if you look at the talent today that is coming to our organizations, everybody is equipped with Python skills. I think in coming 10 years, we'll have a lot of engineers who have used Python in their thesis, in their PhDs and their masters. They have the capability to develop custom tools and solutions which can help in operations and analysis. And this came from our personal experience when such tools were developed in-house. And when we asked our supplier, control center supplier, to integrate that, they said it's difficult. We need to do a lot of changes internally. It's going to take 5-7 years. It's going to take this much money. And that was bad news for us. So I think it was a sign that probably the future control centers, we don't need to be dependent on the vendors and their architecture. We need something that can really support easy integration of capabilities that's coming from multiple vendors, even in-house. And we need to move towards that kind of a mindset. Second is that we still see utilities a bit, having a traditional mindset that, when I'm buying an EMS application or a distribution management system application, it needs to come in a pizza box. The hardware has preloaded application and we just stack it in our server room. That's changing as well. I think there are a couple of utilities, including us, who have developed some kind of more private data center in which you're not reliant on the hardwares and the softwares to be pre-integrated together. So you need the right kind of design mindsets to utilize those kind of technologies. And we need to decouple the applications and the hardware. The idea is that. And systems are becoming more service-oriented, more modular. We want to escape the vendor lock-in systems. So Whenever now we go to support any utility in procuring a control center and upgrading a control center, it's important that we bring in certain kind of design elements to support these non-functional capabilities also that helps reduce our operational costs in future. Apart from that, like I said about the digital resilience, I think what the industry is moving towards is zero trust security. We need a very sound data and cloud strategy to support us, and similarly on the data governance side, which is very critical, the infrastructure and the systems we bring in place, it should be it's like an interconnector, a hybrid interconnector, which Didier was saying. You don't develop or design a system just for one use case. I think the systems can support various other business needs, and the right kind of data architecture needs to support it, needs to be thought about. So that's a bit some of the ideas that we have with respect to the control centers and how we are planning the future ones. Very quickly, on the left-hand side, you see these are the various layers of field systems and the applications in a utility operations. On the right-hand side, you see that the industry has agreed that, okay, in future, these are going to be the 3 key standards, 3 key frameworks under which all the information is going to be exchanged. So from the infrastructure to the operations part, it's IC 61850. Towards consumers and DERs, it's the COSM standards. And for all the information exchanges between business and applications and the various departments of utilities, you have the SIM model under IC 61970. So that's the global migration and target for most of the utilities. And this is a starting point for developing the roadmap for these kind of smart grids. So I just have a couple of case studies. So very quickly, I want to go by this. Today, if you look at a typical utility system, you have multiple vendors. You have a GIS coming from vendor X, you have planning tools coming from vendor B, you have SCADA coming from someone else. So you buy different solutions from different vendors, but you don't have your own data model. So you use the data model that's coming from these vendors. The idea is that we worked on a case study which really helps in creating a unified grid network model, wherein the different data objects that is generated by all these different systems are together integrated into one network model. And this serves as your own single source of truth. Tomorrow, if, let's say, your planning tools vendor or your GIS vendor is gone, changes, you have your own, let's say, data reference to rely on and work. So this protects a bit the vendor lock-in. And a second case study I want to talk about, the recent control center we designed, in which we just don't go ahead and buy a control center at the bottom, all these applications you see at the bottom layer, but we also want to make sure that the interfaces with all the other systems at the business layer is also thought about, what kind of data objects, how it needs to be shared with them. There also needs to be some kind of a view and strategy behind. So here are some of the case studies we do to support utilities digitalization journeys. There's a lot of things to share again, but today was just more like an introductory discussion to tell you from where do we come and how we are a bit different from the typical IT consultants you see out there. We focus more on the operational technologies and the information exchanges we need as utilities to support our operations. Yeah, thank you.
Okay, great. Thank you very much, Lavjit. It's really fascinating to hear, the very rapid evolution for digitalization for the transmission sector. We have about 12 minutes to go, so I really want to just jump into the Q&A because I think there's a lot of questions and interest in both topics on interconnectors and also digitalization fronts. Maybe if we could start with the first question that David has shared. He shared it in the chat group, but David, please also feel free to speak up on this. Thank you.
Thanks, Christine, and thanks so much for the presentation, Didier and Abhijit. My question is sort of trying to build on the lessons learned from Europe and sort of comparing and see what are the challenges in Asia. So really, governments, what we're seeing is they're setting these renewable energy targets are very ambitious, but the way of doing transmission is still the old way. So state-owned and vertically integrated power utilities. Many of them are quite slow-moving and traditional, and so land acquisition permitting still a major issue. So some countries it's really dramatic, like Bangladesh. But in your view, how can Asian countries improve their transmission investment planning? How can they fast track permitting of new renewable power connections and make sure the transmissions line are built, are ready when those projects are concluded? And so what are the lessons learned from Europe? Has Europe really learned from that? And how can you support us in engaging with governments on these topics and helping them improve their planning and regulatory framework? Thank you.
Very good question. Very, very good question. Thank you for that one. What I would say is with renewable integration, there's a big change actually in the way we're planning the systems. In the past, you could plan ahead easily because you knew where generation would come. And it was quite easy to have a plan and to prepare it and stick to it and control it properly. The problem now is, every day you have new changes. One country developing more this and that. You have new generation capacity coming here and there. So it's really difficult to have a plan. And that's a problem. So what we did pretty early in Europe is we introduced the idea of a probabilistic planning. So instead of being, stochastic, or you can, instead of sorry to say we know exactly where we go, we said, okay, let's look at probability. Let's put all scenarios together. So we started from 1-2 scenario. We ended up with 40 different scenarios, but again, difficult to manage. So we ended up with what we call the least regret scenario approach. So you run the scenario, you look at what is the common grounds, what is anyway needed to achieve all those possible futures. And then you can definitely invest there with no regrets. And you know that this investment is a good one. And that's what we do actually today to make sure every investment is a good one. The same for us. I mean, we are not willing to invest in stranded assets. So everything we do has to be well invested. Same in Europe and in Asia. So we developed the tool to make sure grid planning could be made smarter. And then, of course, when everybody knows that investment makes sense in all scenarios, then it's easier to attract financing on that project, both from governments or maybe from time to time from private investors, because they will recognize the fact that investment there makes sense. So I think the way you do planning should be completely changed and also made visible to demonstrate why this is a must-have and not a nice-have. Yeah. And on land acquisition, just on land acquisition is the same. So, in Europe, it's crazy. You need 10 years to build an overhead line or whatever. So again, you demonstrate the value of an asset over time, and that if you don't build that one, the rest will be much more expensive. So then you can start to convince your stakeholder. But it starts with a new way of planning, indeed. Yeah.
Absolutely. The right-of-way issues remains challenging for new build of transmission. Can I invite Eric? You want to turn on your mic? Eric? Hi, Eric, please come in.
Okay. Thank you. Thanks for the presentation. I really like it. And this is, I would like asking David, definitely I need this presentation because I have some ideas to then develop it. I have a lot of questions and I don't know, like if I try to summarize it, or maybe I will try to summarize them in one question. You made me not be answering all of them, but maybe you can say somehow your opinion or whatever. So yes, you touch one issue, which is a balancing market, which is done when you're doing investment on renewable, then you need a balancing of your generating activity. So that is the one. Then we have an issue of regulatory market, which is the model is like investment plus 10% return. So that actually stimulate more and more assets, more and more hardware, more and more. Another one is the conflict between like private operation of distribution under the regulatory, which actually I think that somehow operators are benefiting of being a private company under regulatory model, rather than have a state-owned transmission. And like, I mean, if I continue, then it can be more. Then you have a marketing liberal market, and then somehow in that liberal market you are still balancing or still compromising on a balancing market, and then having. So, can you like how all of these conflicts are working and how this possible? Or that's what I'm saying. You maybe not be answering all of them, but maybe just because I think that the one big one is the reform and the maybe starting with the reform and the reform of regulatory system, then go to investment.
Exactly.
Okay, like,
it would be, even if I was an expert in that domain, I think it would be completely impossible to tell you the magic solution in just 1 minute, because we are still developing the market today. It's becoming very, very complex because we need to integrate everything into that market. You know, the complexity of you know, the intraday, the long-term planning, everything. You know, the flexibility, the ancillary market is developing, and so forth. So my simple answer to you would be, we have been through a long sequence of developing the market from the basic way of operating, you know, cross-border and regional markets, 2 countries, then 3, then 4, then 27. We have been through the complexity of managing first large bulk power, then going into smaller and smaller chunks of power. And now we are entering into the complexity of short time. So minutes, you know, markets. So we've been through all of this, and we made a lot of mistakes. My approach would be, if you want to develop a market like in Southeast Asia or in other places of the world, it would be good to look at the journey we've been through, and then from that journey say, okay, those are the milestones we need to go through because we know it works. Avoid the pitfalls and make sure it's forward compatible, future compatible. That if you do something again today, it will be no regret, because you know that's a building block to enable the next stage and the stage after. I strongly believe that with that experience we've been through, Asia can go 10 times faster in implementing a market, because you know the milestone and you know the pitfalls to avoid. And it will work because you know that these milestones are, let's say, the building blocks of the future steps. So I think it's a very complex domain, but the luck that other countries have is that we have been through that painfully, and you can learn from this journey. Yeah.
Okay, that maybe just another small comment, and that also nowadays a lot of dispatch centers are really complaining. So they're complaining to actually like one, I will not name, but one dispatch center in one country is complained to in development partner that, you know, you're investing in renewables, you're creating a big issue for me. So like, we're creating enemies.
Exactly. Lavjit, do you want to comment on that, or?
Yeah, I think to that one, there needs to be some kind of a root cause analysis to be done at what's basically causing the problems to dispatch. A lot of times they are a bit inefficient in forecasting. I think we need to increase the capability of the dispatch centers to forecast in both the shorter and the medium-term horizons on how it's going to be. And plus, I think there is a lack of tools and there's a lack of capabilities available in the dispatch itself. And I can understand the pain points. And it's also sometimes expensive to deploy tools just like that. You also need people to operate it. You also need skills to run it. So we need to sequentially plan what kind of upgrades, what kind of capability increases are required based on the gaps there. So that's the kind of approach you can take to start somewhere. Again, it's something we can discuss in something more specific later, but that's the high-level approach.
Maybe one comment
Thank
from
you.
my side
Thanks a
is
lot.
tell you is, you know, the classical ways we were doing in operating systems. So in Belgium and Germany, we had two different suppliers to provide us with the SCADA and the, you know, control centers. The conclusion is the same on both sides. It's that technology is obsolete. We cannot use the same technology to operate millions of, you know, of injections in the systems. We need to change the approach. So now we are moving into what Lavjit mentioned. So we're more into AI, you know, new approaches to do smart decisions in complex situations where the human being cannot operate anymore. So we need to go through that transformation. So we are anticipating that. We are, of course, in the running sequence. We are the front runner on that. So Asia is far from it, but you will also benefit from these developments in a few years from here, for sure. But I can understand the frustration of the control rooms, for sure.
Okay, thank you. Thanks a lot.
Thank you, Ray, for that question. I think that really sums up a lot of similar experiences that other developing member countries, dispatching centers, and also vertically integrated utilities are experiencing with that transformation, both digitally and also with you know, the various variable demands on their network system that needs to be adjusted for in their planning, as you have mentioned, with the use of probabilistic models and also the use of AI and machine learning to really make that transition. I know we're at the top of the hour and wanted to see if there's any other questions. Oh, there's one question Priyanta had posed. Oh, last question. What is the cost of the Belgium-UK 146-kilometer interconnection?
That's a good question. It's I need to check the detail. It's roughly, I think it was 700 million at the time. It's a 1 gigawatt interconnector, 400 kV.
Yeah.
There's one thing I wanted to mention on that one is just to give you an idea on it to finance this interconnector. There was a lot of question about, okay, it could be very profitable to private investors, and then people would feel frustrated to say, oh, okay, these guys are making a lot of money. And at the same time, it could also be non-beneficial at all, and so non-attracting any investor. So, you know, this discussion is always like, do we invest or not? We found an approach which we call the cap and floor approach, just in a nutshell, because I think it's very relevant to Southeast Asia. NemoLink operates in a way that if it's very beneficial, so if you generate a lot of revenue from it, part of that revenue goes back to the people and to the tariff, reducing the price of electricity. If that interconnector is not profitable enough, then the investor will benefit from subsidies coming from the tariff. So it's a cap and floor, but it's also a win-win. It's like when these conditions are met, then everybody's interested to push for it. So the regulators say, yeah, I need that, and the risk is limited. And the investors say, yeah, I can generate money. Even if it's capped, it's still okay with me. And then you find a way there to make sure this investment can be done. In the case of NemoLink, at the end of the day, it's not the most profitable for the investor, but it's very, very profitable and very useful for the country as well. So I think it's a nice model to look at, especially when the market is not fully in place. Yeah.
Right. Thank you. Thanks for sharing that. And I know there are also other models within Asia. For example, the tariff-based competitive bidding model in India that has been able to attract private sector investments into the transmission networks there for renewable energy evacuation. That could also be an alternative model versus a long-term concession model that we have here in the Philippines, for example, that would be worthwhile for us to see how that can be optimized, both from regulatory innovations, as you mentioned, and also through technological adoption. There's also another question, colleague, that have mentioned if you just have maybe 1 or 2 minutes. I think this relates to a lot of the areas that you touched on earlier regarding, you know, the increasing complexity of managing renewable energy generation and incorporating that. So the question is from our colleague Ching Yu. who is asking about, how do we address the instability? And I think you had touched on that earlier with how, increasingly you really have to have that real-time data and to be able to respond in a very dynamic manner compared to the traditional approach of dispatch. So if you can touch on that, that would be helpful.
I can answer that. So within, I think, EGI, we on this topic, I think all the practices work together as a unit. So I think the first step is to see when you are putting a certain number of renewables in the grid, what's the flexibility you need to manage it. So this kind of system planning is done by one of our this is a system planning that is critical to that. Once you have that kind of flexibilities in a long-term plan, you need to basically see on your day-to-day operations how many reserves or what kind of primary, secondary, tertiary reserves you need to balance the systems. So for this, we have what we call as the power system operations and studies, where we do all these kind of dimensioning and the flexibility needed in short-term durations. That's how we do it. Third is that, to get all these kind of flexibilities, you need to put the right kind of markets in place. And I think in the current setup in Southeast Asia, there is a good vision, but I think we need to now go in a more execution mode and get those designs in place so that, the flexibility start coming in. And I think the way we've done that in Europe is don't wait for a top-down way of the regulations and designs to come. We see this European Horizon Grant that was successful over the last 10 years, where the donors have funded so much of innovation, so much of pilot programs, where small communities or small kind of projects were set up to demonstrate the efficacy of how the flexibility can be delivered for grid operations. So a lot of stuff needs to be done on the market side. And then again, on the operation stuff, you need visibility of how the system is progressing and performing. Then all the tools that you have offline, online, coming from the dispatch centers, control centers, they support there. So yeah, there's a lot of different things you need to look at to address that thing, but there is a holistic approach one can use.
Maybe just quickly on that one. So indeed, not only you have high variability of generation, but everything now is controlled by power electronics. So the interconnectors, power electronics, the wind farms, power electronics, the PVs, power electronics. So everything is interacting with everything. It's a lot of control loops into the thing, and the stability depends on how these loops work. So 2 words: specify properly your asset. So if you buy the wrong controller, then you are into issues. So, specifying properly and then being able to simulate how things will work, to anticipate. And all of that, I'd say we develop the tools and expertise to run. But the specification of the right asset is the starting point, just to avoid introducing, issues in the system. Again, transmission assets are critical for the economy. I keep saying transmission assets are the most important assets a country has, because no power, no economy, right? So you want to make sure you keep the lights on. And so for us, having a deep look into how those things work and make sure it's stable under any kind of circumstances is critical. So very good question indeed. And yeah, you need to be careful with that.
Great, thank you so much. I think that's a really important aspect. One point I wanted to also just bring out, again, fantastic discussion and really excellent presentation, Didier and Lovejeet, and thank you, Rajesh, for making this happen. And also, just to echo what one of our colleagues have also mentioned, Keju's recognizing that he sees this as a lot of possible applications and opportunities within the ASEAN region interconnectivity project, and also with the Philippines offshore wind development that's ongoing, and you probably have been seeing a lot of recent news on that as well, and also in the Pacific Island economies, where there will be need for more interconnected and digital grid transformation. So with that, I know we will continue to have a lot of discussions in the coming days ahead, but really appreciate and thank you, Didier and Lovejeet and Rajesh, for joining us today. It's been a really, I think, critical discussion to have on transmission for energy transition in developing Asia. So thank you so much for our discussion today, and thanks everyone for your participation.
Thank you.
Thank you. Thank you very much.
Thank you very much.
Thank you very much, everyone.
Have a good day.
Have a great day. Thank you. Bye-bye.
Thanks, everyone. Great job.
Bye.
Thank you.